Hello, good evening everyone. Live center. Silong is there, right? How are you, Silong? Lenam and San, right? So what is your attendance? Both are present and only one. One. So is it Lenam? Do you have any camera? Very good, Lenam. Thank you. Dear, tell me, do you have any camera in the classroom? So in the last class we have started parabola. All right, not an issue. Let's focus now. So in the last class we have started parabola, okay, and we have defined all the basic terms related to any conic. And remember, lattice rectum, axis, vertex, focus. So this is all common to all three conics. These all kind of definitions now will be common to all three conics. So do a quick revision first of all, right? Then we will start in 2 or just 3 minutes. You just go through all the pages. Okay, what is eccentricity and how it is different for your parabola, your ellipse and your hyperbola, right? And what is exactly the meaning of eccentricity? Right? We take the ratio of two distances. So make sure what kind of distances they are. In the numerator we have distance between 2 points, distance of the moving point from the fixed point, right? And in the denominator we have distance of the moving point from the fixed line, which is directrix. So when we take these two ratios, it will be known as, it is known as eccentricity. Clear? So eccentricity is equals to 1 means both the distances are equal. What conic we get is parabola. And if E is less than 1, that will be your ellipse. And lastly, if E greater than 1, it would be the hyperbola. Alright? So I have given you 3 questions as your homework. There were a total of 5 questions, out of which I have solved 2. Okay? And there were more 3 questions. So can you tell me which exactly these 3 questions were? Can you provide me just that data part, like vertex was 0, 0 and so on, right? You don't need to write the entire that information. You just tell me, I have the question, I'm not sure which particular question is that, right? So you just tell me the figure, that data, right? Vertex is 0, 0 and directrix or focus. Provide me the coordinates, simply. Alright? So, yes, Lenam, can you send me those 3 questions? Just write vertex and then have a bracket, like in the braces you can write that 0, 0 or whatever the coordinates are. Please. Not responding. Why? Please, you have to tell me because I'm not sure which 3 questions. Well, yes, I remember there were one question. Vertex 0, 0. Question is, vertex is 0, 0. Okay, not an issue, beta. Let me recall. Right? Vertex is 0, 0 and passing through. And please do not forget to bring your copies, because that's a really important note. If you are not carrying a copy right now, so you would be writing somewhere else, right? As a rough note, I would say. But again, you have to write it on your actual class notes, right? Because everything should be there. So make sure you are writing in a proper way in the class right now, and you can attach these pages, particularly these 2 or 3 pages, which I'll cover today in the actual class notes, right? You can paste it somewhere, or you can just, using the gum or tab you can use. So try to paste it there. Vertex is 0, 0 and passing through the point 2, 3 and axis is along x-axis. Alright, so let's find out the answer. Now, what should be the standard format? What kind of figure it would be? So it is along the x-axis. If we have axis along the x-axis, means whether it is x square, y square equals to 4ax or y square is equals to minus of 4ax. Clear? Now, y square equals to minus of 4ax cannot be the answer because it has the curve in this left side, remember? But as this curve is passing through 2, 3, so certainly it has to be this one. Clear? This one. So my format is this one. Y square equals to 4ax. Right? Why we can consider y square equals to 4ax? Because vertex is given 0, 0. Is that clear? Passing through 2, 3, so let's find out the value of a now. As 2, 3 passing point, as parabola passes through 2, 3, therefore 3 square equals to 4 into a into 2. So here we get 9 equals to 8a. What is the value of a? A value is 9 by 8. Hence, equation of parabola, it will be y square equals to 4ax, which is y square equals to 9x by 2. Is that clear? Nine by 9x by 2 is the answer. Very good. Now there is an important note which you should remember. What if your vertex is not at 0, 0? Note, if vertex is h, k instead of origin, right, which is 0, 0. So if instead of origin we get h, k as the vertex, then we have y minus k whole square. Basically what will happen now? Every x and y will be converted into, y minus k as x minus h. I'll show you how. This is called shifting of origin. Shifting of any coordinate. So suppose we have, x goes to x minus h, y goes to y minus k. I'll show you how, right? This is the case when vertex is at origin. This is when vertex at h comma k. So every equation will be like this. Y square equals to 4ax. Now this will convert here. Y minus k whole square equals to 4ax minus h. Clear? Y square equals to minus of 4ax. So that will be y minus k whole square equals to minus of 4ax minus h. X square equals to 4ay. So this will be x minus h whole square equals to plus of 4a y minus k. X square equals to minus of 4ay. So that will be x minus h whole square equals to minus of 4a y minus k. Alright? So these are the conversions you have to do. Ask me if any doubt. Basically, if I ask you a question, find out the equation of parabola whose vertex is, right, whose vertex is at 3, 2, and axis is parallel to. Now, of course, axis cannot be directly x-axis and y-axis. They cannot be directly, but this time they will be parallel to the x-axis and y-axis. Vertex is 3, 2 and axis is parallel to x-axis, and it passes through 6, 8. Right? Let's find out the equation of parabola. So what you have to do is, now this time, of course, I mean, if it is not, vertex is not the origin, then there is no point of saying that axis will be parallel to the x-axis or y-axis. I'll show you in the diagram. It's very obvious. This is your xy axis, coordinate axis, right? This is y, this is x. Now we are saying that vertex is at 3, 2. So this is somewhere vertex 1, 2, 3. This is 1, 2. So here we get 3, 2. Right? 3, 2. Now I'm saying that it is, parallel to the x-axis. So this is the shape of parabola. Like this. Getting my point? Maybe this one or maybe this one. I'm not saying this is the only possibility, but yeah, this also be the possibility. But as this point is saying 6, 8. So certainly if this is 3, so it is 4, 5, 6 and somewhere 8. Clear? So this is the correct curve. This is the correct curve. Okay. Now you see. And this is nothing but the, what happened is basically from when your vertex becomes 3, 2, now everything is like this, right? This will be the vertex here 3, 2 and this is the axis, right? Anyway, if you have to write the equation now, so that will be, let the equation of parabola be y minus of 2 whole square equals to 4a x minus 3 whole square. As axis is parallel to the x-axis, so we can consider this curve, not a square. We can consider this curve. I hope you understand. Passing through 6 comma 8. So 6 comma 8, let me put here 8 minus 2 equals to 4a, 6 minus 3. We get 6 square equals to 4 into a into 3. So a equals to, this is 36 and 12 into 3. So that will be, 12. So it will be 3. A value is 3. Is that clear? A value is 3. So once you will get the value of a, hence your parabola equation is y minus of 2 whole square equals to 4a, 4 into 3 into x minus 3. X minus 3. Is that clear? So we get y square plus of 4 minus of 4y equals to 12x minus of 36. So we get y square minus of 4y minus of 12x plus of 40 equals to 0. That's your answer. Clear? So this is how we are getting the final equation that you can solve once you get the exact idea how to write the standard equation for this given situation, right? If you shift the vertex, if you shift the origin, instead of origin you get the vertex at some h comma k point, so accordingly we have to subtract it. This process is known as, in mathematical language we call it shifting of origin. Well, there is we can do 1 or 2 classes over that, but again that is not important for boards. Once we will finish the board part, then I'll take all these coordinate, particularly for JEE means. But we need to make sure that we are finishing boards first. So right now this much is useful to you, right? It will be, a lot of if vertex is at some h comma k, so accordingly we have to subtract that. Clear? Clear? Very good. So I'll give you 1 or 2 more questions and please try to solve, right? Please try to solve. Question is, find out the vertex, focus, directrix, lattice rectum, right? And parabola equation we have is y square minus of 6 minus of 8y minus of 12x plus 22 equals to 0. Find out the vertex, focus, directrix, lattice rectum, right? All that like what are the lattice rectum length, length of lattice rectum, what are the extremas or the end point of the lattice rectum, and of course the equation of that lattice rectum line segment. So try to solve this. How it is different, I'll tell you how it is different from the actual conventional question. As you can see clearly, it will be some y minus of k whole square, right, equals to some 4a times of x minus of something h, right? So what we have done in the last class, it is not same as that, but it will be, involving some kind of shifting of origin. This is actually based on the same note here. What we have covered today, it is same. I'll tell you how to solve this. This is very, favorite question of JEE Mains. Not in your boards, I think. For now, I have seen so many questions not in boards. So make sure accordingly, those who are actually focusing on mains, they have to be very serious about this. Otherwise, in boards, it is not. I'm just telling you, So those who will not understand and not looking for JEE Mains, not an issue for them. So let's find out the y minus k factor, like the standard equation. Let's convert that. Completing the square, right? So it will be y, as we have 8y, so I have to consider y minus 4. Now, y minus 4 whole square will give you y square plus of 16 minus of 8y. So of course it is same, right? 8y, but we have added 16 extra, so I have to subtract. Minus of 12x plus of, this is we have 22 equals to 0. Clear? So this will be y minus 4 whole square, and this is, let me take all the x in constant term in the right side. So it will be 12x, this is plus 6, and here it is minus of 6. Right? Y minus 4 whole square equals to, now what is the main idea here, right? Idea is you have to take 4a common and x will be inside. So if you take 12 common, it will be x minus half, right? X minus half. Do you understand what is the meaning of this y minus 4 and 12x minus 1 by 2? I'll show you what. Y minus 4 whole square equals to, this is what? 4 into 3 into x minus half, right? So now you can understand, this is y square, this is some y square equals to 4a and x. 4a capital X, right? What I'm saying is this is some small x, suppose y small. This is taking, we are all small y and x. So here we are saying capital Y and capital X. I'll explain it one more time, don't worry. This is the equation of curve, of course, but if we want to find out the vertex, the focus and the other parameter, so for that we should convert it in the standard form, because whatever the result we have, right, that is only for the standard curve. So what does that mean? That means, let y minus 4, here I am saying this is y, smaller y, right? Just to make it different, this is x, sorry. Let me write it again. This is y minus 4, small x, all small x, y minus 4, x minus half. So here I am taking this as capital of y, okay, y equals to y plus 4. Anyway, similarly, x minus half if you take as capital X, so it will be x equals to capital X plus of half, right? Now, if you consider this, then you will get capital Y square equals to 4 into 3 into capital X. Is that clear? Say yes or no. Because once you will understand this part, there is nothing more. See, because when you will convert here, so that means for this system, right? For this system, let me write here, for capital XY, right? And here the actual answers which is in small x and y, right? Guys, just give me a moment. I'll show you how to find out these answers. We always do this, right? We will make a table, and as we know, for this system, we know all the answers. Like, first of all, vertex. So, vertex for this capital XY system, what is the vertex? It is 0, 0. What does that mean? That means capital X equals to 0, capital Y equals to 0, right? But what is the R system? What is R system? Small x and small y, right? Our system is small x and small y. Here I am taking small all, right? Just to make it clear, you don't have any doubt. So this is all small. Here we have started with capitals. So we will find out all the answers with respect to vertex's origin. We have done this in the last class also. And here, in terms of small x, small y, this relation we will use. That means, when capital X, capital Y was 0, 0, so what are the values of x, y? This will be half and 4. Is it clear? Half and 4. Half and 4. Of course, this is the answer, right? Half and 4. Clearly, you can say, sir, answer is vertex will be half, 4. And this is I have shown you actually. This side, in this system, in this column, you see, I have proved how we are getting this half, 4. Is that clear? Second is the focus. Now, what is the focus? Focus in this system is always what? A, 0. I mean, A, 0, right? So, that will be A, 3, 0. Now, focus on this, right? This is we are getting 3, 0. Now, dear, how we will get these values here? So, you see, again, you have to put capital X. This is all capital X, capital Y. Capital X, capital Y. Right? So, if capital X is 3, what is the value of small x? It will be 3 and half. So, that will be 7 by 2. 3 plus half, comma, 0 plus 4. So, what you are getting is 7 by 2, comma, 7 by 2, comma, 4. Alright? Yes or no? Axis. Now, what is the axis? Axis is y equals to 0. X-axis is the axis, or x-axis. So, right here y equals to 0. Capital Y equals to 0 is the axis. There is no rule of x, right? So, if y equals to 0, what is the answer here? It would be, if y is 0, I mean capital Y is 0, so what is small y? Small y is 4. So, small y equals to 4 is this answer. I hope you understand. Next is lattice rectum. Ends of lattice rectum. So that is what? It is always a comma 2a, a comma minus 2a, right? So what is a? A is 3 comma 6, and we have the other one is 3 comma minus 6. Is it clear? A comma, let me write here, a comma 2a and a comma minus 2a. Please memorize, please recall it. We have done this in the last class. 3 comma 6 and 3 comma minus 6. So here we get, now when x equals to 3, capital X is 3. So what is the value of small x? 7 by 2. When capital Y is 6, small y is 10. So this will be 10. And again, 7 by 2 comma minus of, not minus 10, sorry. 7 by 2 and minus 6, right? Minus 6. Y is minus 6, so minus 6 plus 4, it will be minus 2. So small y is minus 2. I hope you are getting this plus minus thing, right? The simple relation we are using from this to this, whenever you have to convert this to this, the relation we are using is y as y plus 4 and the small x we are using is capital X plus half. Right? For conversion. Capital X system to small xy system. Fifth, equation of lattice rectum. Equation is what? X equals to A. It is line vertical to, vertical to the axis or parallel to the y-axis. So that is x equals to A, 3. So what is the answer? Small x would be 7 by 2 is your answer. Last one. Sixth, length of lattice rectum. Length of lattice rectum is always 4a. Okay, so that is nothing but, let me write here. If you remember na, 4a, length equals to 4a, right? Okay, so what is the length here? 4a, that complete 4a, 4 into 8, 12 units. Now what will be the length here in small xy system? Same, 12 units. I'll show you why. Length, area, volume, these are all physical quantities which do not get altered with the shifting of the coordinates. Right? Suppose if you take an example, like if this is the coordinate system. If this is the coordinate system, which is 0, 0 as the origin we have, and these are your conventional x and y axis. Right? Now, if I have a rod, like, right? I have a length basically. This is some point A, B. It is a line segment A, B. Now I'm saying that if you shift the origin somewhere here, some h, k, so your new axis x dash and y dash you will get. What will be the length of this line? Length will be same, line segment length will be same. The only thing which gets changed is the coordinate. So for this you can remember a note, this is very important guys, remember in case of shifting of origin, only coordinates changes. Whereas length, physical quantities like length, area and volumes remain same. Is that clear? So that is the reason as length of lattice rectum is the length, right? It is the length. So that will be same. Whether your parabola is having vertex as 0, 0, if you shift somewhere here, right? Somewhere here. I think this is clear. You see, coordinates are being changed. Equations are being changed. Why? Because again it is x equals to 3 is a coordinate, right? Or the equation itself. But the length, it doesn't get changed. Let me write here one more thing. In case of shifting of origin, only coordinates and equations changes, whereas physical quantities like area, length, volumes remain same. Okay. Now please revise it thoroughly. How we are solving this question. You will not get this question in the boards, but again I'm telling you, you can expect this kind of question directly in the JEE mains. They will give you a simple equation just because you do not do practice on this kind of problem in the board exams. So yeah, this becomes kind of favorite problem for JEE mains. It is easy, but again, if you know it how to solve, then only you will be able to solve it. Clear? Clear. Very good. Very good. So let's move to the next. Next topic is ellipse. The next conic will be ellipse. All right. So let's define first of all what is ellipse in terms of eccentricity, and we have one more definition for ellipse that we will also write. So definition one is basically again regarding the eccentricity. So let's write it. It is the set of all moving points in a plane it is the set of all moving points in a plane whose ratio of distances from a fixed point to the fixed line is less than unity. Right? This is simple what we have mathematically now. We just defined it in the same manner, right? Without even changing the, any word. Like it is the set of all moving points in a plane, right? Whose ratio of the distances from the fixed point and the fixed line is less than unity. That means E less than 1. In case of ellipse, first of all, always remember E will be less than 1. Right? Some points which you have to remember, but I'll show you as a note. I'll write it. So this is definition number 1. Definition 2 is in case of ellipse, basically, I'll tell you, there's a difference between parabola and ellipse. As in the case of parabola, we were having only one focus, one directrix, but here will be two focus, two directrix. Let me show you here. Then it will be easy to define then, right? So suppose if we have this diagram, this is the actual ellipse. You can refer to x square upon a square plus of y square divided by x square upon a square plus y square upon b square equals to 1. This is the equation of this ellipse. Now clearly it is a closed figure, and you will have F1, F2, two foci. This is called the center of the ellipse. These are called vertex. Okay. Anyway, I was just, telling you that, there will be total of two directrix. Right. Directrix 2. So directrix 1, directrix 2. This is your focus 1, focus 2. And what are these lengths? There is a name for these lengths also. Don't worry, I'll show you in the different diagram. Is that clear? So let me take this as, okay, here only I'm doing A and A dash. This is your B and this is B dash. Basically, what is A coordinate or A dash? A or A dash are the points, this is x-axis and this is y-axis. So how can you get this A and A dash? This is the intersection point of the curve of the ellipse with the x-axis. That means y equals to 0. When y equals to 0, you will get x equals to plus minus a. This is nothing but the same point. Let me write here A and A dash. How you will get A and A dash? A will be a comma 0. A dash is minus a comma 0. What is B and B dash? Similarly, B will be 0 comma B, and B dash is going to be 0 comma minus B. Right? This is C or O, right? Origin. Now this A dash, let me write here what is F called. F1 and F2 are the foci. Focus is the singular term, but when we use two focus, it will be foci. It will be a plural term. F1 and F2 known as foci. C, origin, that is the center, right? These are called vertex. A and A dash, only A and A dash are known as vertex. So basically vertex is always same. Vertex is the, what we have defined for vertex? Vertex, we have the intersection point of the conic with the axis. Now things are quite complicated in case of ellipse, as we have two axes. We have different names for those, don't worry. I'll define it one by one, all of the terminology we will define, and then it will be more clear to you. Okay? But yes, I'm just giving you a brief idea of this. This is the center, this is called, we call it A dash, and then there will be more terms like what is AA dash. This AA dash, total distance AA dash is known as major axis, this is the major axis. BB dash will consist, or the minor axis will consist of BV dash. Right? This is the major, this is the minor axis. Okay? Also remember that value of E will be root over of 1 minus B upon A to the whole square. Or, which is also on solving, you can write as A square E square equals to A square minus of B square. Yes. What is the value of E? Value of E would be 1 minus B upon A to the whole square, or which is same as this. A square E square equals to A square minus B square. I know things has been messed up. I know, totally I know. But I'm just giving you the idea. You please write it for now. And now I will take you to the actual standard form of the curve. And remember guys, this value of E we will be using. Value of E is root over 1 minus B upon A to the whole square. I can explain over there only how it is less than 1. Always, you see, 1 minus something is square. So this is always positive. You agree? V upon A to the whole square number is always positive. Is that clear? Always positive. And of course, we take A is greater than B. Here we take A greater than B. That means, if B is less than A, that means this whole quantity will be less than 1. Now, 1 minus something less than 1 means it is positive but not greater than 1. So, in totality, what should be the value of E or range of E? So, that would be from 0 to open 1. Or, it would be less than unity. Simple. Less than unity. Alright. Let's define the standard ellipse now, one by one. Standard ellipse. Alright, so let's define one by one. This is the x-axis, this is the y-axis, this is the O origin, this is B, B dash, A dash, F1, F and F dash. Let me write here F and F dash. Because we are using A dash, B dash. So, better if I write F and F dash. Alright. So, let's define one by one now everything. Again, the very first heading, which is vertex. It is the intersection point of ellipse and the major axis. It is the intersection point of ellipse and the major axis. Major axis means this x-axis here. Separately, let me define. Focus we know. Focus we all know, right? Focus I'll not define. Directrix I'll not define. Directrix is here in this case. This is one directrix. This is second directrix. I will relate with the diagram also. Don't worry. That distance relation I'll show you here. Just give me a moment so that I can define first. Second is major axis. Axis which contains the focus is known as major axis. Axis which contains the focus is known as major axis. Clear? So as this, there are a total of two axes, I mean one and second, right? But as focus is lying on this particular, the x-axis, so for us it is the major axis. Third is minor axis. Minor axis. Now what is minor axis? Which doesn't contain. Axis which doesn't contain the focus is known as minor axis. Clear? So vertex we have defined, right? Vertex we have defined. We have defined what is the major axis, what is the minor axis. So of course semi-major axis would be this O to A, or O to B is the semi-minor axis, right? Okay, I think enough of new term we have defined now. Let's move to the table part, right? Table means these are the terms like one by one, and here we have x square plus of x square upon a square plus y square upon b square equals to 1. First we have vertex. So what is vertex? Vertex we will get A, which is a comma 0, and a dash, which is minus a comma 0. Second, center is basically that origin, origin, which is also called the point of symmetry, also known as point of symmetry, known as point of symmetry. Clear? Third, major axis. Major axis. Major axis is basically the x-axis or y equals to 0. Right? What is the length of major axis? Length of major axis means a dash, right? Between the intersection point or between the vertex point. Length of a dash, which is also the major axis length. Length of the major axis. So that will be what? Twice of a, clearly. Of course, I mean, if this is a and this is origin, so a plus of a, twice of a. Fourth point, minor axis. Minor axis is y-axis or x equals to 0. And what is the length of minor axis? That is b dash. So that is what? Twice of b. Next, focus. So there will be a total of 2 focus. One is F, other is F dash. So what is the F? F is AE comma 0. F dash is minus of AE comma 0. Lastly, directrix. Directrix is, this is the directrix, right? The first directrix, this one, the second is this one. So what are the equations? Always remember, this point is basically plus of A by E comma 0, and here it is minus of A by E comma 0. So equation of this line would be x equals to A by E. Or x equals to minus A by E. It's not or actually, dono. It has to be both and. Right? So x equals to A by E and x equals to minus of A by E are the 2 directrix. This is all about the standard ellipse. Clear? This is the minor axis, right? Minor axis. This is, this is the major axis. Any doubt? And yes, one more thing. Directrix we have defined lattice rectum, right? Lattice rectum. Lattice rectum. So what is the length of lattice rectum? Again, equation is same. It is always passing through focus. You remember that? Let me define it as, these are the lattice rectum ends point, right? This is one lattice rectum. This is the second lattice rectum. This is, I am saying, L1, L1 dash. This is L2, L2 dash, right? Now, let's find out the endpoints of the lattice rectum. So we know that it is always passing through the focus, right? So x is fixed. X equals to AE is fixed. Now we have to find what is the y coordinate. The upper y, the lower y, the left y, the all kind of. So lattice rectum or the length, the ends of end point of the lattice rectum are nothing but the points or the intersection point of that line x equals to AE with the ellipse. If you solve for x equals to AE with the ellipse, you will get the y coordinate. So here x square AE upon A square plus of y square upon B square equals to 1. So here we will get E square plus of y square upon B square equals to 1. Further, y square upon B square equals to 1 minus E square. Okay. 1 minus e square. Y square upon b square equals to 1 minus e square. Now what is the value of 1 minus e square? Can we get from somewhere? 1 minus, yes, from this you see. What is the value of 1 minus? So here we can solve e square equals to 1 minus b square upon a square. So value of 1 minus e square is this one. You please write all the formats. You have to remember all these three formats. First one, the second one, and this is the third one. I mean, this is not that important, but yes, you only remember this, and if needed, you should be able to convert. So what is the value of 1 minus e square, guys? B square upon a square. Let's put it here. So on solving, we get y square equals to b raised to power 4 upon a square. So what are the values of y? Plus minus of b square upon a. We have power of 4 now, so that will be square. And in the a square, you will get only a. So now y equals to plus minus b square upon a, right? Hence, what are L1? L1 would be a comma b square upon a. L1 dash will be a comma minus of b square upon a. Okay. Similarly, what is L? L2? L2 would be, L2 is in the left of the origin, so that would be minus of a plus b square by a. L2 dash would be minus of a comma minus of b square by a. Is that clear? Finally, length of the lattice rectum. So that will be twice of b square by a. Why? B square by a, it is basically the perpendicular distance now. So above the x-axis, it is b square by a. Below is also b square by a. So twice of b square by a. This is the length. Always remember lattice rectum length. In case of parabola, it was 4a, and here it is 2b square by a. It's important. Is it clear? Let's do a question, and then we will discuss the other form of the standard ellipse. This is called the horizontal ellipse, right? Question is, Question is find the coordinates of the foci, the vertices, the lengths of major and minor axis. Minor axis and the eccentricity of the parabola. The ellipse. 9x square plus of 4y square x square plus of 9y square equals to 36. Try to solve. Find the coordinates of the foci, the vertices, and the lengths of major and minor axes, and the eccentricity of the ellipse. So again, we should always write down first of all, we should always write the standard form of any conic, whether it is parabola, ellipse, or hyperbola. So let's start with that. Rewriting. We get x square upon 9 plus of y square upon 4 equals to 1. If you divide by 36 on both the side, it will be x square upon 9 plus y square upon 4 equals to 1. So here we get a greater than b, right? A greater than b. As in the denominator of x square is higher than the denominator of y square, that means a square is greater than b square. So a is greater than b. Now this is definitely this curve. We should always plot a crude diagram. This is the curve. This is how it will look like. Right? Okay, let's start finding all the values now. What is the value of E? Let's find out value of E. Also, E is equal to 1 minus of B square upon A square. So that will be root over 5 by 9, which is equals to root 5 by 3. Right, so this is the value of E, root of 5 by 3. Is it clear? First, vertex. Vertex is a comma 0 because it is the standard curve whose major axis is the x-axis. So definitely vertex is always a comma 0. Now what is a comma 0? 3 comma 0 and minus of 3 comma 0. Second, where is the foci? Foci is ae comma 0, right? ae comma 0 and minus of ae comma 0. So that will be root 5 comma 0 minus of root 5 comma 0. Third, foci we are done, vertices we are done, length of major and minor axis. So length of major axis. Major axis length would be twice of A, 6 units. Length of minor axis. So that is what? 2 into 2, which is 4 units. Right? Fourth one, the last point. Length of lattice rectum, suppose. Length of lattice rectum would be 2b square, which is 4 by 3a. So 8 by 3 units. So these are all answers. Is it clear? Now, as in case of parabola, there were total of 4 cases. If it is right-handed parabola, left-handed parabola, opening upward parabola, opening downward. So again, here here in this case of ellipse, we also get two cases. One will be horizontal parabola and one will be the vertical parabola. It's again in reference to the major axis. If your major axis is the x-axis, then it is called the horizontal ellipse. And if your major axis is parallel to the y-axis, or it is in the y-axis, so that is known as the vertical ellipse. Is that clear? But I think that I should not take this, the second case in the same class, because it will be difficult to understand. You guys will not be clear that much if I take both the cases today. So I'll cover this only for the day. I'll give you some more questions, some more questions. Question is, find the equation of the ellipse with major axis along x-axis and passing through the points 4, 3 and -1, 4. Find the equation of the ellipse with major axis along the x-axis. That means, yes, the standard curve. Means you should consider, let the equation be of ellipse be x square upon a square plus of y square upon b square equals to 1. This is the equation of ellipse we can consider. Now we have two unknowns, a and b, and we need two equations. So yes, we are given, because passing through the points this 4, 3 and this. So we have two conditions. Condition 1, passes through 4, 3. Let's have the equation. Equation is 16 upon a square plus of 9 upon b square equals to 1. Okay. 2. Second condition is given, that passes through -1, 4. -1, 4. So this will be 1 upon a square plus of 16 upon b square. 1 upon a square plus 16 upon b square equals to 1. equation 3. Now our target is to solve equation 2nd and 3rd and get the values of A and B. So let's solve this one. Equation 2 and 3. From equation 2 and 3, so guys, what you're supposed to do is you have to find A and B, right? So we have two equations, equation 2nd and 3rd. Okay. So now what we can do is if I multiply here with 16, okay, so what do I get? 16 upon A square minus of 16 upon A square, right? 16 upon A square plus of 9 by B square equals to 1, and here after multiplying this it would be 16 upon A square plus of 256 upon B square equals to 16. Okay, now if you subtract it, so these two are cancelled, we get minus of 247 divided by B square equals to minus of 15. So B square value is 247 upon 15, which is correct, right? So what is the value of A square? Let's find out. 1 upon A square plus of, this is what? 16 upon B square. 16 upon B square. B is 247 upon 15 equals to 1. Let's find out A square. So that will be 1 upon A square plus of 16 into 15. So that will be 240 divided by 247 equals to 1, which is further 1 minus of 240 divided by 247, which is 247 minus of 240 divided by 247. So guys, it will be 7 by 247, 1 upon A square, right? Okay, so finally we have the value of A square also, which is 257 divided by 7. Clear? 247 divided by 7. Hence, equation of ellipse you can write as x square upon 247 divided by 7 plus of y square divided by 247 divided by 15 equals to 1. This is the answer. This is the answer. Clear? X square upon 247 by 7 plus of y square upon 247 by 15 equals to 1. Is it clear, everyone? This is all the horizontal ellipse. Please remember all the coordinates, like what is focus, right? What is the directrix equation? Directrix is again what? A by E. In this case, x equals to A by A. X equals to minus of A by E. Now I'll show you in the diagram. I was saying now that I'll show you in the diagram how these ratios of the distances will be less than or greater than unity. You please copy it first, then I'll tell you. Well, we are done for the day. In the next class, we will discuss the another case of ellipse, which is the vertical ellipse, where y square, the denominator over y square will be higher than the denominator of x square. So yes, focus will be on the y-axis, major axis will be along the y-axis, and major axis is also the y-axis likewise. Alright? Now I'll show you in the diagram. If you take the coordinate axis, the conventional one, the standard one, and here we have the ellipse, right? Okay, if this is the ellipse and this is the directrix, focus is somewhere here. Now, basically, this point is what? AE comma 0. This is what? A comma 0. And this is what? A by E comma 0. You agree? All feet of perpendicular. So, coordinate you will get A by E comma 0. A comma 0, AE comma 0. Is that clear? So, now you see if you take any point, let me take this point. This point. So, distances of these 2 points, like P1 here, suppose P1 and this distance. So, what I am saying is that PF divided by P1F divided by P1M will be less than 1. This is what I am saying. P1F, P1, these are all moving points. Sometimes a point is here, sometimes point is here, this point, and this point. So this is nothing but it is set of all those points. Clear? P1, P2, and if you consider such infinite points on the curve, they will be satisfying this particular characteristics. Right? P1F upon P1M is less than 1. Clear? If you were to do it, if you repeat it, it's somewhere here, P2. So, this will be the case. Basically, the distance, the moving point, distance of the moving point from the line is higher. From the fixed point, that is lower. Clearly, it is higher, it is lower. I mean, this is higher, this is lower. It is higher, it is lower. And remember, if your moving point is suppose in this direction, so make sure the focus you are considering now, the corresponding, whatever the focus you consider, you should consider the same or the corresponding directrix. If this focus, this directrix, right? If this focus, then this will be the directrix. Clear? Okay, so guys, yes, very good. So at the end, I'll define in the second definition. I was telling you that there are 2 definitions how we define ellipse. So let's write down the second definition. It is important for boards. In general also, you should remember this. Definition 2 is, in ellipse, sum of the distances of the moving point from 2 fixed points which are actually foci, right? So in ellipse, sum of the distances of the moving point from 2 fixed point is always constant. Also, PF plus PF dash equals to 2A. That constant is nothing but 2A. Is that clear? Where what is A? A is the semi-major axis. 2A is the major axis, so A will be semi-major axis. Is it clear? PF plus PF dash is 2A. I'll show you in the diagram how it is. If this is your diagram, or in general if you consider, this is the ellipse. Now guys, if you take any point, let me complete this. This is F dash. if you take any point P, suppose P here, right? So I'm saying is that PF plus of PF dash, this distance plus distance is 2a. If you take somewhere here, suppose P1, so this distance plus this distance PF plus PF dash is again 2a. If you take some P3 or P2, so these distances again, summation of these two will be same. P3F plus P3F dash equals to again 2a. So all are equal. So let me conclude this. Basically, what happened is, ellipse is such a geometry in which, the moving point, distance of the moving point from the two fixed point, I mean PF and the PF dash, sum of these two distances of the moving point from the fixed point is always same. Sometimes it is P, sometimes it P1, P3 and so on. So all these are the moving points. So they will, when you will draw a curve along your, using all these points, you will get the ellipse. This is not that important. I mean, most of you will not understand, but again, just in case if there is something given that distance from the fixed point is given this. So fixed point are nothing but the focus, always remember, right? So distance, kind of what distance is given now, that will be PF plus PF dash equals to 2a, where a is the semi-major axis. So this much will be enough. All right? And don't worry, I'll give you some question on this particular property, so you will be more confident on this also. All right. So is there any doubt, anyone? Lenam, is there any doubt, beta? All right. So take care, and again, I'm not giving you any homework for now. Your homework is you have to revise the complete notes, and I will give you question, but when we will done both the cases, case 1 and case 2. Case 1 we are done, the horizontal ellipse we are done. Now we have to do vertical ellipse, but in the next class. In the next class, I'll give you homework. Is that clear? So take care everyone, and good night, and do revision regularly, which is very important. And start solving or start practicing those chapters which you have missed or you have not practiced good. I mean that much, right? So you should do that in this free time. All right. Take care everyone. Bye-bye. We'll see you in the next class. Good night.